Hi everyone, I am Dr. Kiran, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today we are going to learn field effect transistor applications. Let us see the overview of today's presentation. So we start with introduction, FET as a voltage variable resistor, FET as an amplifier, FET as a switch, and conclude with summary. So coming to the introduction, so FET is a three-terminal device and two PN junctions are there, and it's a voltage variable device. So FET is a unipolar device depending solely either on electron or hole for the conduction. So for the FET, electric field is established by the charges present, which controls the conduction path of the output circuit without the need for direct contact between controlling and controlled quantities. It has high input impedance. It can be used as amplifier switch. So let us see the first one, that is FET as an voltage variable resistor. So if you see the characteristics of FET, so these are the first part. So left part is ohmic region, and in this region, so let us draw clearly. So here VDS and this is ID. So if you see, there is a linear relation between output voltage VDS and output current ID. So if you see here, there is a ohmic region. This region is ohmic region or linear region, because here VGS is ID is directly proportional to VDS. Hence, we can say VDS is proportional to ID. So here the slope. So when we decrease, so if you see, this is VGS is equals to 0 volts. So when we decrease VGS, the drain current also decreases. So this is because the resistance increases. So when we increase this negative voltage between gate to source, the drain current decreases because the pinch off condition occurs early, and correspondingly the resistance also increases. So this is the basic property how FET act as a voltage variable resistor in this region. So the left portion of the characteristics is the ohmic or linear region. The slope of each curve and therefore the resistance of the device between drain and source for VDS less than VP are a function of the applied voltage VGS. As VGS becomes more and more negative, the slope of each curve becomes more and more horizontal, corresponding to an increase in the resistance level. The following equation provides the good first approximation to the resistance level. So that is the resistance between resistance of the FET when gate is shorted, that is we can say R0. What is R0? R0 is the resistance of the FET when VGS is equals to 0. Whereas RD is the resistance of the FET for a specific value of VGS. So that means when VGS is equal to -1 volt, -2 volts, -3 volts. So like that. So therefore, that can be represented by this RD. RD equals to R0 by 1 minus VGS by VP whole square. Now, let us see FET as an amplifier. So if you see this FET as an amplifier, this is the symbol for N-channel FET. So we know to act as an amplifier, FET must be operated in active region. So active region means input port must be forward bias and output port must be reverse bias. So when the input here, so these are the capacitor 1 and capacitor 2 is also there across the output. So capacitor 1 is used to block the DC, and CS is the bypass capacitor which is used to it gives the low reactance path to the current, output current, that is, so IS source current. So if source current flowing through this RS, then there will be more voltage drop. So if more voltage drop means there will be some decrease in the gain. So gain will be decreased, signal strength will be reduced. So if you see this R1, R2, RS forms the voltage divider biasing network in order to maintain proper operating point, and this voltage divider network makes your transistor, your FET operated in the active region. And now input and output. If you observe the input and output, so there is a 180 degrees phase shift. So this is because when the input voltage increases, it causes the drain current to increase. So drain current also increases when input increases, which in turn leads to decrease in the voltage at the drain terminal. So obviously output side. So resulting in the invert signal relative to the input. So this is about transistor as an amplifier. Why the 180 degrees phase shift between input and output. Now let us see FET as a switch. So this is the circuit diagram shown here. It is series shunt switch. So depending upon the position of the FET, we can have two types, shunt switch and series switch. And we know when we want to use this FET for switching applications, so it must be operated in either saturation region or cutoff region. So when VGS is applied to is 0, then VGS, gate to source voltage, is off, then FET is turned on. So when FET is turned on means operating in saturation region and its resistance is very small. So current flowing through the nearly 100 ohms. The output voltage across the FET is Vout is equals to Vin into RDS by RDS plus RDS on. So that is opposite resistance by total resistance into input voltage. That is the output voltage. Since the resistance RD is very large, the output voltage is approximately considered as 0. So when we apply negative voltage which is equal to pinch off voltage at the gate, FET operates in the cutoff region and acts as a high resistance device, and it does not allow current to flow. Output voltage is equal to the input voltage because here it is opened. So whatever the input we have applied, it directly goes to the output. So V0 is approximately equal to Vin. This is about a shunt switch. And now we can also have a switch in series. So FET is connected in series to the input. So in such case, obviously it must be operated either in saturation region or cutoff region. Now it acts as a closed switch if the control voltage is 0, and an open switch if the control voltage is negative. So there are two conditions. When the given control voltage is 0, then it acts like a closed switch. When the given in control voltage is minus, so negative voltage is applied, then it acts like a open switch. So when FET is on, the input signal will appear at the output. Obviously, whatever the, because it is connected series. So series switch. So therefore, output is approximately equal to input in this first case. And when it is off, the output, because if it is on means whatever the input, it comes to ground. When it is off, opened, then whatever the V0 is less than Vin. So that is the condition, two conditions. Okay, so that's all about applications of FET. So summary, so from the introduction, so we have discussed what is FET as voltage variable resistor, and then FET as an amplifier, and FET as a switch. So most probably next topic will be MOSFET, metal oxide semiconductor field effect transistor. Thank you.